Assalamualaikum and hi everyone. So today my group C1C from OCC1 will be answering the question using the dataset 7. I'll be presenting question 1 with Yasmin, followed by Jasmine for question 2, Putri for question 3, and Adlin and Wana for the last question. Hi, my name is Ning Ersha Ilya with the matrix number 22002626, and I'll be covering the first part of the question, which is 1A. So the question asks us to construct a normal probability plot based on the data set that was given to our group, which is dataset 7. So there are 5 steps that can be taken to answer this question. So the first one, I sort the each variable in ascending order in the column which I name as ordered value. Next, I calculate the cumulative area using the formula alpha equals to 1 over n plus 1. Next, I try to find the empirical z-score using the formula x minus mu over standard deviation, and I also find the theoretical z-score using the built-in function in Excel. Last but not least, I construct a normal probability plot with theoretical z value as x-axis and ordered value h as y-axis. So in this slide, we can see that there are two figures, which is the first one is the table with 6 columns that I constructed in Excel, which covering all the steps that I mentioned just now. And the second one is the constructed normal. Moving on to the next question, question 1b. The question asks us to refer to the previous normal probability plot and conduct an appropriate test to assess whether the mean age of respondent differs by gender. So before moving on to the first step, I would like to explain a bit about the previous graph as it is related to this question. So by referring to this normal probability plot, we can see that there is a presence of extreme outliers, particularly at the higher end of the graphs. So how do we know there is a presence of outliers? Is because we did the calculation of the outlier range, lower bound and upper bound. After calculating, we see that there will be an outlier at the lower bound less than 17.375, and for the upper bound is 34.375. So from the plot, we can actually say that there is a few of the points that is beyond this range. For instance, 17 years old for the lower bound and more than 35 years old for the upper bound. So there is presence of extreme outliers. Therefore, the plot that we constructed previously is a non-normal probability plot. So moving on to this question, we have to conduct an appropriate test. So the first step to conduct this test is to state the null and alternative hypothesis. So in this question, the null hypothesis is when the median male is equivalent to median female, while the alternative hypothesis is when the median male is not equivalent to median female. So the second step is to select the level of significance. Since the question did not mention any specific levels of significance, we assume to use the levels of significance alpha equals to 0.05. The third step is to determine the appropriate test statistics. So as I mentioned just now, the previous plot is actually a non-normal probability plot. Therefore, we will be using non-parametric test, which is the Mann-Whitney U test. Why do we use the two tail instead of one tail? This is because in the question, it doesn't specify any specific criteria. For instance, like who is younger or who is older. Therefore, we just want to know whether there is a difference or not. So we'll be using the two tail test. So the fourth step is to state the decision rule. So we will reject H null if the z-score is greater than 1.96, which we can refer to the Z table. Next is to compute sum of ranks for each sample, and the next one is to compute U statistics and Z statistics. So since we conducted a two-tailed Mann-Whitney U test, there will be two U values. So how do you know which value we will be using? So we will only use one value that is smaller from the other one. So in this question, we'll be using the male U values, which is 1320.5. So by using these U values, we will now conduct the Z statistic test. So after calculating, the Z score that we gain is actually negative 1.4409. So for the last step is to make decision and conclusion based on these two values, Z values and P values. So for the Z value, negative 1.400 negative 1.4409 is less than 1.96, while the p-value 0.1946 is greater than 0.05. So there is actually no sufficient evidence of statistically significant difference in the median age between genders. Therefore, we fail to reject the null hypothesis which is the median male equal to median female. So in conclusion, there is actually a difference between the median age for both genders.
Hello everyone, my name is Marina Yasmi binti Shara Azli and I will be presenting the solutions for question 1C and 1D. Let's begin with question 1C. What is the probability that the sample mean age is greater than 26 years? To answer this, we use the Z-score formula for the sampling distribution of the mean, which is Z equal to the sample mean minus population mean divided by the standard error. The values given are the sample mean is 26, the population mean is 26.9, the population standard deviation is 6.777, the sample size is 120. Now we calculate the standard error, which is sigma divided by the square root of n, which gives us approximately 0.619. Next, we calculate the z-score and we got z is approximately negative 0.1455. Next, to find the probability that sample mean is less than 26, we use the standard normal distribution, and the formula is 1 minus probability of z less than negative 0.455, so the final answer is 0.927. This means there is a 92.7% probability that the sample mean age is greater than 26 years, assuming the true population mean is 26.9. Question 1D, what is the probability that the sample mean age falls between 23 and 25 years? Again, we use the same z-score formula and we already know the standard error is 0.619. Now let's calculate the z-scores for both values. Z-score for 23 is negative 6.304 and the z-score for 25 is negative 3.071. Next, we find the probability between these two z-scores, which is the probability of z less than negative 3.071 minus the probability of z less than negative 6.304. Then after subtract the probability that we got is 0.0011. This means there is only a 0.11% probability that the sample mean age is between 23 and 25 years. If the true population mean is 26.9 and the sigma is 6.777. In conclusion, question 1C shows a high probability of the sample mean being greater than 26, while for question 1D shows a very low probability of it being 23 and 25.
Hello, my name is Jasmine Hazura binti Haslin with the matrix number 221107009, and I'll be presenting about question 2A and 2B. So firstly, question 2A asks for construct a 90% confidence interval for the difference in proportions of passengers who are satisfied with the two measured items under facility quality. So starting with 2A, 2A's objective is to compare the facility quality. So we first looked at two items under facility quality, and which is FQ1, sufficient seating capacity in the train, and FQ4, clean and good condition of waiting areas. We calculated the proportions of satisfied passengers, those who gave ratings of 4 or 5, and the results show that FQ1 had a proportion of 50.83% and FQ4 had a proportion of 59.17%. We constructed a 90% confidence interval for the difference in satisfaction proportions, which was minus 0.1886 and 0.0219 for the upper limit confidence interval. So since the interval includes 0, this means that there's no significant difference in passenger satisfaction between the two facility aspects. So passengers are generally satisfied with both seating capacity and waiting area conditions. No specific area stands out as significantly better or worse. Both seem equally important to the passengers. Now, moving on to 2B. So next, we tested whether female passengers report higher satisfaction than males using independent samples t-test on two items, which is PS1 and PS3. So for PS1, the female mean is higher than the male mean, and the t-value is 0.73 with a critical t of 1.658. So overall result is not significant. And for PS3, the female mean is lower than the male mean, and the t-value is minus 0.14, which is also not significant. So overall, in both tests, the t-values were below the critical value, meaning we failed to reject the null hypothesis. There is no evidence that the gender has an impact on the satisfaction level.
Today I'll be presenting our analysis on the factors that influence passenger satisfaction with RRT services. We used data from a quantitative survey and applied two statistical tests to answer our research questions. Initially, we considered three tests, which are the paired sample t-test, one-way ANOVA, and the Vince test for homogeneity of variance. Out of this, we selected the first two based on their relevance to our objectives. The paired t-test was used to compare satisfaction levels before and after passengers use the service. We used two variables, which are FQ1 and FQ4. The test was conducted in Excel, and the p-value we obtained was 0.0769, which is definitely greater than 0.05. This means that there was no significant change in satisfaction over time. Next, we use one-way ANOVA to see if education level affected satisfaction. We grouped respondents into 3 categories: high school, bachelor's, and graduate or above, and compared their PS1 scores. The p-value was 0.9404, again, which are not statistically significant, so education level didn't impact how satisfied passengers were. In conclusion, we found that satisfaction remains fairly consistent over time and does not vary across education levels. This suggests that other factors like punctuality or service quality may be more influential.
Hello, my name is Putrina for Adeline, holding matrix number 240555490, and I'm gonna go to the question chi-square test, which will measure how a model compares to observed data. So these are the steps, and the data that we choose is gender and private transport ownership because the data fit the characteristic, which is categorical variables, and also there are step, which is we go to stating the hypothesis and also finding the alpha value. The alpha value that we choose is 0.05, which is the most common, and this is the null hypothesis and also the alternative hypothesis for these findings reports. And then we go to the next one is we create contingency table. This is to make it easier for us to understand or to find the chi-square value, chi-square stat. Step 3 is degrees of freedom. So degrees of freedom for this data is 1. So how do we get that? We minus 1 from the number of rows and multiply with minus 1 from the number of columns. And then for the next step, which is we find p-value and also chi-square stats. P-value we can just find from the data, it's 0.558. And then the x-square stats or the chi-square stats is 0.7645, which is the alpha from 0.05, which is actually 3.841. And then we go to the conclusion and we compute that if the p-value is greater, so we fail to reject same as this from this data. And then same goes to the chi-square stats, which is we also fail to reject the H null because it is lower than the alpha. Moving on to the next question, which is man with EU, we use this is to compare two samples or groups. So these are the steps. The data that we choose is gender and also clean and good condition of waiting areas, which is this is a level of satisfaction. The reason was because these two are independent groups and the condition of waiting area level of satisfaction is ordinarily the same, like the hypothesis and also the alpha value, which we still use 0.05 because it's the common one. And this is the raw data and also the rank, the data that we already rank. And step 3 is sum of rank. So we find the summary of, or we add all of the rank from females and also males, and then we find we find the use stats, so using this formula. And then step 5 we find the z-score, so p-value from the use stats. There are 2 types of conclusion, which is using p-value. We still fail to reject because the p-value is higher than the significant level that we choose. And then the z-score, the total is, the value does not fall into the rejection area, so we still fail to reject. That's all.
Assalamualaikum and good day everyone. My name is Ridwana Afamiti Muhammad Aminuddin and my matrix number is 2300293. Today I'll be talking about the solution for question 4C, which is the Kruskal-Wallis test. So for this question, I selected education level as the independent variable and PS3, that is satisfaction with safety and security, as a dependent variable. PS3 is measured on a 5-point Likert scale from 1 that indicates very dissatisfied to 5 that indicates very satisfied. As for education level, it includes 3 groups, which are high school or below, where n equals to 38, bachelor's degree, n equals to 67, and lastly graduate or above, where n equals to 15. So as shown in the summary table, all 3 groups had the same median score of 4, with mean scores of 3.79, 3.81, and 3.73 respectively. The null hypothesis for this test is that there is no difference in PS3 satisfaction across education levels. For the results, the Kruskal-Wallis test give a test statistic H of 0.377 and a p-value of 0.828. Since the p-value is greater than 0.05, we fail to reject the null hypothesis. So the box plot here is to support the results, showing very similar distributions across the group. In conclusion, education level does not significantly affect passenger satisfaction with safety and security on the
And
LRT.
I think that is all from our group. Thank you for having us, and we hope you guys understand what we have explained before. Thank you.